Okay, well, this will be very difficult to explain, but what I'm working on is a temperature management system for my smoke unit. There's a heater coil inside there, and it gets hot, and then it creates smoke. And then sometimes, since this is the design of my part for my American Flyer trains, I have to be careful with the temperature, the amount of temperature that we allow it to build up to. If it gets much over 140, it can damage, melt, and soften the parts, and then they fail. So what I've been working on, because we have a 17 volt transformer, is how do I get 17 volts through here? Well, you can if you put in like a 30 ohm heater, but with a 30 ohm heater, you don't get any smoke until you get to 9 volts. And at low speed, you have no smoke. Well, we got to have smoke at all speeds. That's the way trains work, right? So I tried to come up with a low speed smoke system, and I found that I needed to lower the voltage all the time, just about. So what I came up with was a voltage regulator system. But my problem was, when we have a fan now cooling, driving the smoke out, it actually cools the heater, and then you lose the smoke. So how do we do that? So then I was working on my, oh look, my part's done. I was working on my 3D printer, and I had to change the nozzle, and I damaged my thermistor. Well, it wasn't really even clear what that was, but I did learn over time that it is a sensor that tells the machine temperature, and then the machine does something with that. Well, when I repaired it, I had to buy 5, as I recall. So I have 5 of these things, and I took one out, and I played around with it, and I realized that I could put that thermistor down inside my heater and watch the heat of the heat. Well, okay, now what? Well, if I knew the heat was building up too high, there is a device. It's called sort of a chip. It's right there. It's a voltage regulator, but it's variable. This is an LM315, I think, or 317, something like that. And it has a way of using resistance to measure resistant variables and then adjust the voltage output. What? So that if this gets hot, the resistance in this wire goes down, and it senses that, and it says, I need to, or no, is that right? No, as the temperature gets hot, the resistance goes up. As the resistance goes up, it realizes, and I have adjusted a threshold, and it says I have to turn the heat down. I have to turn the voltage down going to the heater. Now, right now, I have a temperature sensor sitting around here at about room temperature, which isn't really any great shakes. And if I stick it down in this hole, or if I can get it caught in some fashion, it'll give us an idea of the temperature of the heater. And then I have this thermistor sitting supposedly pretty much on top of this thing, so it can measure the temperature. Now, and then I have my little fan here that turns on the battery that turns on the fan, and I'm going to turn this thing on. I'm going to turn it on at 30 miles an hour. So we now have the transformer telling the engine to go 30 miles an hour. As it's doing that, it's actually putting out about 9 volts, 8.9 volts, something like that. As it's doing that, this power is coming into this fellow, and it's shooting power out, and it's shooting power out at just about 5 volts. Now, I've got my fan on, and I'm blowing the smoke, and it's saying, yeah, okay, you can do that. But if you start blowing too much smoke, I'm going to cool off, and if I cool off, I'm going to turn that power back on. Look at that, 6.6 volts, because I'm turning the fan on. And the beauty is, you will have smoke. I know it's leaking like a sieve, but that's okay. you will have smoke all the time, even as the temperature is dropping. Now if I turn the fan off, the temperature is now increasing inside there, so the voltage is dropping as the temperature is increasing. As the voltage drops, the temperature drops. 4.5 is nothing, right? So now I turn the fan on, I got some smoke going on here, the temperature is dropping, the voltages are increasing. As the voltages increase, temperature increases, smoke increases, it gets too cold, it turns the voltage back up, it starts warming up, and the idea is we have smoke all the time, and we're not overheating, not even close to overheating. Oh, this is so tough. There's the diagram. Took me a while to figure it out. I did the math about 1,000,000 times. I got turned around, I got confused, I had the ranges wrong, I had the numbers wrong, I measured this wrong. Anything you could do wrong in a high school science project, I did it. I didn't measure the weight of the ice, I didn't dry the water off the ice before, on and on and on. I got there. So now, my tools, my resistor substitution box allows me to dial in a resistance, which I did. I started out way over here, it had nothing, I don't understand it, so I moved it down, I found the range, the zone I needed to be in. I've got 4 multimeters here, all doing something. And one doing temperature, one doing volts, one doing resistance, one doing volts on the input, volts on the output, blah, blah, blah. Okay, great. Now, this guy has to get a reduction in size, and what I'm going to do is build a LM 7809 9 volt volt regulator. I don't know if that's 9 volts or not. I think that might be the one. Yeah, I think it is. So I'm going to have a 9 volt regulator, and it's going to look a lot like this, only smaller and simpler. So I'm going to have a 9 volt regulator in the tender of the engine. Right off the track, go to 9 volts. Send that 9 volts to this little assembly, which will be much smaller, more compact, little bundle. And I'll have 2 wires coming in and 2 wires going out. 2 wires coming in are going to be the temperature, and the 2 wires coming in going out will be the power to the heater. And then 2 wires coming in will be the 9 volts. That's it. Everything else will be contained. Won't have this big box, of course. It'll all be down there. I'll get a 1,000 ohm resistor somewhere and stuff it in that, and we'll see how it goes. Then we mount that in the boiler so that the fan service, if you will, is now automated, self-tuning, or I don't know what you call it, self-regulating. I can't do it with one hand, I'm so inept. But as soon as I start blowing smoke and cooling this down, voltage starts. Now my target voltage was 675. And you can see the smoke's leaking out. I have no screws in this thing, but it's going to be just fine. It's going to be just fine. And as it gets hot, temperatures drop to 425. The voltage drops to 4, temperatures start to rise, voltage comes down, temperatures come down when I turn on the fan, voltages climb right back up, and smoke is coming out of the steam engine all the time. It's amazing! It's amazing! I've been trying to do this for months. I've bought parts, I've built stuff, equipment, mathematics, all this. It's not hard. It's just not something I do on a daily basis, so it was new and unique. Took me a while. But I think we're on track. I know we're on track. It's going to be awesome. Okay. I'm going to button this up a little more, make it a little more tidy, try to do another video later. Voltage regulated, heat regulated smoke generator for American Flyer. Ba boom.